Hi everyone, welcome to the R tutorial for bioinformatics. This is the beginner's edition, and so what we are going to do is to do a general overview of the R programming environment. I've assembled some codes here which I believe every beginner should know. So we'll go through them line by line. I will explain them, and then by the time we are done, hopefully you have a general overview or you have a general picture of how the R environment operates. All right. So it's going to be interactive as usual. For the codes I'm using, everything has been compiled into a single R script. So if you want that R script, you can check the description box. Down link to that script is there. So without further ado, let's start the exercise. So when you open RStudio for the first time, you are going to see something like this. So what we want to do is to create a new R script, and then we will write our codes there. So we'll go to File, then click on New File, and then go to R scripts. All right, and then you can have it. This is RStudio, by the way, but it's possible to also do everything on the terminal. Okay? But RStudio works for the most part for all of us. So let's use that. So in RStudio, this part here, what we did, now we have this session which we will use to write our codes. And then when we run the code, the output will be displayed here. Okay, so that's what we are going to do. So we write our codes, we will run them, and then we will check the output here. So let's get started. So in R, one of the things that you will do is use a print statement. So print statement allows you to display items, okay, or allows you to display outputs. Okay, so let's start with that one. So let's say print statement. Okay, so print statements, that's how we use print statements. Okay, I'm giving you an example, but there are a couple of ways to display items on the screen. Okay, I'm giving you just one example. So I can just say print hello world. All right. So here, once I'm done, I can come to run. And I'll click it. When I click it, I'll have the output here, right? Alternatively, if you don't want to use the cursor or the mouse, you can just use the Alt key and then the Enter. Alt and Enter. So the Alt on your keyboard, there's a key with the label ALT, that's Alt. And then you press the Enter key, or some will also say Return key. So the Enter key, so press Alt and then Enter at the same time. Then that line of code will be executed. Okay. So this is the print statement. You can also print numbers. So let's say 1. Okay, that's what we have here. So these are things that you need to know. Okay, so that's for the print statements. It's very simple and straightforward. So try with these two examples, and also try with variations of them. Maybe use different text here, a different number, and then see the outputs. Okay, now let's look at assignments. Now in program, one of the things that we do is to assign values to variables. All right. Okay, so let's just say you have DNA, just a variable, right? Like this. If you want to assign a value to this variable in R, you type your variable, which we have done, and then you bring your less than symbol and then the minus symbol here, like this. Then you give your value. Since this is a bioinformatics channel, of course, let's start with some nucleotides. So I can say ATGC. All right. Here I'm using double quotes, and here double quotes. Please follow this. I will explain the double quotes in a later session. So for now, please follow whatever I'm doing and try to do the same. Don't bother about anything. Just try this, and then we'll proceed. I will explain everything. I repeat, just try to follow me, do exactly what I'm doing, and then I will explain the meaning of these two double quotes later on. Okay, so we have done our assignment. Of course, I'll have to execute that line, which I've done. So in RStudio, whatever command you execute, it will be shown here together with the output. Here, there will be no output. It's just an assignment task. Okay. Once I'm done, of course, I can even say print statements. I can give the print statement. So I can say print DNA. Okay, so print DNA, and I have it here. So ATCGC. There's a sequence. Okay, just a simple sequence. All right. I can also say, let's say DNA-seq. Let's put it this way. I like this name. ATCGG. Let's put it this way as well. So here I'll just say print DNA-seq, and I'll see it there. Okay, so let's say number 20. I'll run it. Then I can say print number. Right, so that's what we have. So here with the print statement, we use the values directly that we can assign to variables like this and then run. I repeat, here we use the values themselves in the print statement, but here we assign the values to variables and then we displayed. Okay, which we do by calling the variables. So that's what we have here. So it's very, very simple and then straightforward. Now let's look at the next thing. So in R, all right, one of the things that you'll be doing is to install packages. So this, we are going to do a short exercise here, all right, because the package we are going to use, we need to install it in case you don't have it, because we will use it in later sections of the video. So I want us to take a break, and this break here means that we are going to do an installation. So in R, when we install packages, there are different ways, but one of the common ways is to use the install.packages function. So I want us to install a package. Okay, let's try to install a package here. Okay, so let's install a string R package. We will use it later on, so I want us to install that one first. So I will say install.packages. I'll say string R. So let's execute this command. Okay, so the package is being installed now. I think it's even down now, so we will see how it goes. All right, so the package has been successfully installed. So once it's done, you will see some messages like this coming up, and it will also show you where it has been installed. All right, so for mine, it has been installed successfully, so I can proceed. So let's continue. So now it's time to load the packages. So to load an R package, we simply say library, and we give the name, a string R. We will load it. Okay, so it's been done. Okay, so that's what we want, right? So please make sure to install this package and try to also load it. All right, now we can proceed. Okay, so we are now going to look at data types. Let's just do it this way. So I have data types. Okay, so for data types, you know, when you are programming, you supply all kinds of information. All right, so whatever you supply, they have been grouped into categories based on their characteristics or properties. All right, so that's where data types comes in. Okay, so the data types simply means that the information you have, they have different characteristics, and because they have different characteristics, they have been categorized into what you call data types. So you should know these data types and know when to use them, how to use them, and then where to use them, because each of these can be used for in specific situations. So it's important to know them, and then we can proceed. So we will start with the first one, which is numeric data types. Okay, it's numeric. So we have it like this. So with numeric, I'll give two examples here. We have, I'll simply say numeric integer. Okay, let me just do the label here. That's even better. So the first type, I would say numeric integer, whereby that one, these are integers. Okay, for example, 10 is 1. Okay, 10 is a numeric data type, but it's an integer. Okay, that's what we have here. Now, if you really want to check the data type, you can say class. Let's say numeric integer. Let's look at the class and to give you numeric. Okay, so we have numeric integer. We also have numeric float. These are all numeric data types, by the way, but I have added the integer and float as extra descriptions. All right, but they are all numeric. So if I say 1.2, okay, that's a float, but it's still numeric. If I say class numeric float, I still get numeric. Okay, so you can also convert one to the other. If it's in float, you can convert to integer. If it's integer, you can convert to float. But this is something that we are going to do in detail later on. For now, just know that we have a data type called numeric. So numeric, your numbers can be integers or floats. There are other data types as well, but we are looking at the common ones. Later on, we can discuss about other ones. So I will take you through a lot of them. At least those ones that will help you get started when it comes to programming. Okay, so let's proceed. Now let's also take a look at characters. I repeat, the next data type we are going to look at is characters. Okay, so here, if you've learned other programming languages, then what you should note is that in our characters, we can also say they are more like strings. Okay, in other programming languages like Python, and we call it strings. Okay, so for those who don't know Python, I also have a playlist for Python. So if you want to learn Python, just check the description. There's a playlist for Python for beginners. So characters, we put everything in quotes. Okay, I'm going to show you an example, so you don't have to worry. Earlier on, we did this. We said DNA, seq, and we gave some nucleotides in double quotes. I'm using another group of nucleotides here. So this is a character. Okay, or let's say character because we have several of them. So let's execute this. Then I can say class DNA seq. Okay, so this is character, data type character. It doesn't have to be multiple, it can even be a single one. So if I say, let's say nucleotide equals A, it's still a character. Okay, so I can say class nucleotide and I'll get character. So it can be 1, it can be 2, it can be 3 more. So far as they are in single quotes like this or double quotes like this, they are data type character. I repeat, so far as they are in single quotes or double quotes like what I have here, they are characters. All right, they have the character data type. Okay, to put it that way. So this is for the character. Now with characters like we have here, or let's say strings if I'm translating to other programming languages, you can also do manipulations, right? That is why we have to install this first. Okay, so if you have not installed this package, please install because we are going to use that here, right? So take note of that. With numeric, we can also do our computations, but we will do that in another session, okay, later on the video. For characters, let's look at them because we are bioinformaticians, we are biologists, we deal with, some of us deal with nucleotide sequences, so it's important to know how to manipulate some of these information in R. So for example, if you have your DNA sequence, you may want to check the length. It's a character. So with characters, if you want to check how many characters are there in that variable, you can just say nchar. Let's say nchar. You can say DNA seq. This will give you the number. It's 8 when we count 1, 2, 3, 4, 5, 6, 7, 8. It's 8. That's why we have it as 8 here. Right. Now you can assign the whole operation to a variable. So you can say seek length, and you say nchar DNA seek. So now if I print seek length, I have 8. All right, so it's very, very simple and straightforward. Okay. So that's for the data. Since we are dealing with sequence, you can also add. Okay, you can add as well. So let's say you want to add. Let's say concatenated, or let's say the new seek. Okay, new seek. Let's say we are adding. Okay, we just have to say paste 0. So we have the current sequence plus the new one. Let's see, All right, so let's execute it, and then let's run. So when you run it, we have the new sequence. All right, what is that? Because we added, we concatenated it. Okay, this concatenation. So we can also do that. Now let's look at another thing. Now, if you are dealing with nucleotides, let's say sequences, one of the things that you may want to do is to count the individual nucleotides. So let's just say we have our DNA seq here. I'll also define it again. We want to count the number of A's in it. I'll just do it again here. Let's recreate it. We have ATC, ACTA. All right. So let's just say you want to count the number of A's. And it's A. You can just say A counts. Or let me do it this way. So the function is str count. Okay, so this function can be found here in the string R package. That's why we have to install it. So please make sure to install string R package so that you can have access to the str count. All right, the string count. So I repeat, please install using this command to install the library and then load it. Okay, I repeat, install the string R package and then load it. And then once you've loaded it, you can have access to the str count package. So to count, let's say for example, A. So you have str count, you bring from where, or let's say from which variable or from which sequence do we have to count. So it's DNA seq. And then what are we counting? That's A. Okay, so what are we counting from? Where we are counting from? Okay, so we have it like this, and then we run it. So we get 3. Okay, so here we have 3 A's. 1, 2, 3. Right. Now you can assign the whole operation to a variable. So you can say A counts. We say str counts. We say DNA seq. We say A. Let's use double quotes. Single quotes also fine, by the way. So we have it like this. So let's run it. So now we have it in a variable, and you can make reference later on. If I say print A counts, perfect, I have it there. All right. So that's what we have. That's the power of programming. All right. So if you have a long sequence, it becomes difficult trying to do the analysis manually. So that's where programming comes in handy. So with programming, R, Python, Java, whichever, you're able to write codes like this that are able to take your data and then analyze it for you, and then you can get your outputs and submit your reports. Okay, so that is what we are doing here. So as a beginner, please try to follow the tutorial and try to make some notes as well, and then we can proceed. For those who want to support, there's a link that you can use to also buy me coffee. So check the description box, you'll find the link there. Okay, so let's proceed. Now let's look at the other data type, which is logical. Okay, so with logical, we have two values, true and then false. So you can have either true or either false. Let's look at an example. Let's say bool value, or let's say logical. Okay, let's say logical value. So it can be true like this. Now in R, true can also be written as this. Let's say logical value true. You can also say T. So any of them is correct. All right, so let's run them. All right. Now, if I say class logical value, I see it there. Okay. For false, to is the same thing. So it's false. Let's see. Logical value 3 is false or F. So any of them still works fine for you. All right. So that's it. Okay. That's for logical. Now with logical, you can also ask some questions, and then what will return to you is a logical value. All right. So for example, we have A count. We counted the number of A's. It's 3. If I say A is less than 10, okay, this is an object is not found. Good. So because we have not defined this variable, it's not there. All right. If I say A count is less than 10, then I'll get true. All right. So you notice that here. So in programming, the same thing, garbage in, garbage out. If the variable does not exist, then you get an error like I did. If it exists, then the result will be returned to you. So A count is truly less than 10. That's why it's true. If I said A count is greater than 10, it's false because we know that 3 is never greater than 10. Okay, so here I'm making a statement that 3 is greater than 10, but it's not true. It's false. So that's why we have false here. This one is a true statement. So we have true. So these are logical. Okay, so you can give some commands and then the outputs are going to be logical values. So that's what you need to also take note of here. All right. Now we are going, it's getting interesting. So let's proceed. Now let's also take a look at something else here. We will now look at another data type, which is vector. Or you can also say vectors, that's fine. Any of them is fine. All right. Now, vectors are a list of variables of the same type, right? So that means that in a vector, you can have several characters or several logical values, or let's say several numbers in it. It's more like, let's put it as a container. Okay. So let's say, for example, let's say you have an orange. An orange is a data type or it's a fruit. So if let's say you have a basket full of oranges, all right, that becomes a vector because you have several of that same data type there. Okay, oranges. The basket is full of oranges. So that's kind of how I was playing a vector. So a vector is a list of variables of the same type, a list of values of the same data type. So that's how it is. So let's look at some examples here. I think that will help us get the full picture. So let's say we have, let's say, num vector. So for vectors, if you are adding more than one, so we say C brackets, and you can put 1, 2, 3. So let's run it. So now we have it this way. So here, if I say class num vector, it tells me it's numeric because I have several numeric values in it, but it's a vector. That's what you need to. So it's a vector because we now have several items in it. So if you want to check how many items are there, you can just say length vector. That will give you 8. So we have 3. Okay. So because it's more than 1, it becomes a vector because it's now a container. Okay, so this is the number vector. We have 3 items in it. It's 3. Okay. Now let's also look at car vector, the same thing. So here, let's say ATC, let's say JJA. Okay. Let's just put this to, or let's even add more. Let's say, let's add something else. Okay, so we have something like this. Okay. So we have it in triplets. Of course, we could have changed the T to U to get us codon, but at least we get a gist. All right, so this is also a vector. Okay, if I just say length car vector, I have 4. That's what I have here. Now let's try this. If let's say I should say n car vector, let's see what happens. It tells you what? 3, 3, 3, 3. So n car, that means it's picking each of the characters and it will give you the length. So we have 3, 3, 3. So instead we have 4 items which are of the character data type, and then each of them, the length is 3. Okay, but if you want the length of the vector itself, how many items are there? That one, it's 4. We have 1, 2, 3, 4. So that is 4 character vector. Now for each of these data types, I have some detailed videos on them. Some of them too, I'm currently working on them, which we pick them and then go into details for that data type. So if you want to read more about these data types, just check the description box for links that highlight each of them individually. So those are separate videos. There's an introductory video, and so we are taking it very simple, slow. We can also do same for logical vector. I think I'll put some comments here. This numeric vector. This is character vector. We also have logical vector. So of course with logical vector, you know what to expect. So we have what? 2, F, cos. Yeah, we can do something like this. So again, if you do class, logical vector, we have logical. All right, so that is what we have here. So it's actually very, very simple and interesting as well. Okay, now let's proceed. Now there's another data type which we call lists. All right. So list is also, let's say, container. Okay, but the difference between a list and a vector is that in list you can put several data types together. You can have character, you can have numeric, you can have logical, etc. So that's the difference. All right. Okay. So let's even do this. Let's try this first before we proceed. So let's make sure everything is in order. All right. Now for lists, if you want to create this, you add the word lists. Okay. So let's say lists. Okay. Let's say lists. Example. So for lists, you say lists. That's the word. And then you can bring your items in it. So here I made mention with a list, you can put in several data types, or let's say different data types. So I can say car vector, I can add that. I can add logical vector. All right. I can also add numeric vector. Let's see if I had it there. That's num vector. let's just do this here. Num vector. All right. So let's run it. So I have it there. Now if I say class list example, I have the list. If I type list example, you have the items there. So you have them here. Now with lists, okay, you can do something like this. Let me just show you. Not just lists, but with characters as well, the vectors. Let me put it that way. You can do what's called indexing, where you select a specific part. Okay. Now we know that if let's say I do length, let's example. I have 3. Okay, because we have 3 items in it. If let's say I want the first item, let me just use this word indexing. I can say let's example 1. I'll get it there. Okay, now in R, counting starts from 1, unlike languages like Python where counting starts from 0. In R, counting starts from 1. So if I want the first item or the first element, I have to use 1. Okay, so take note of that. Now that's indexing. So I can do for the list. If let's say, let's look at the car vector. Let's say 1. I also have it there. So for vectors 2, you can also use that indexing. So 1 or 2 or 3, depending on which you want. Okay, you can also do for more. Let's say if you want 1 to 10, it's also possible to do, but those are things we'll cover in detail in other videos. All right, so take note of that. So that is for list. Now let's also look at data frame. I believe this is something that if you are doing analysis, you always come across. So we are also going to look at that as well. So for data frame, let's create one. We can say data.frame. Then we will specify our columns. So let's say numeric, or let me just use uppercase numeric. It will be equals to num vector. Let's add something else. So here, okay, yeah, num vector was 1, 2, 3. Let's see, yeah, this one. Okay, so with data types, I will rather shift to this one. I will shift to these ones. Yeah, if you are creating data frames from your variables, then you need to make sure they are of the same length for the most part. There are ways to go around, but at least to be safe as a beginner, make sure they are of the same length, right? So here I'm going to do this. I'm going to recreate things I will use in it. Okay, so I'll do this. For data frame, you need your columns. So that means you need to have your values ready. So I'll just do this. I'll just do the car vector again. Okay, let's see. This time I'll say A, B, agent, C, and use 4. So that's the car vector. Now here it says A will not find function. Why? Because if I'm creating a vector, I don't have to use A. I have to use C. Okay, so this command will give me an error, but if I use C, then I'm going to get the right answer. Right, so sometimes you may make mistakes, but you need to go back and check and make sure you are using the right syntax. All right, so that's what you need to know. Now, when we come to numeric, or let's say num vector, let's say 1, 2, 3, 4. I have that also done. Let's say logical vector T, T, F, T. Okay. Here again, I get an error because the C is not there. And so I have to bring the C. Sometimes when we are typing, you may have some typos. So when you see them, just check, then do the needful. It will be fine. Right? So you do it, you have it there. So now I can create my data frame. So I'll say df, then I'll say data.frame, and I'll define my columns. So I'll say numeric equals non-vector. Then I'll say logical equals logical vector. Then I can say character equals char vec. So now I'll execute this command. Perfect, it's done. So now I have my data frame. If I say class df, it will tell me data.frame. Of course, since it's data.frame, data, that's df. Okay. I can just print it like I did. I can also print it this way. Let me now use the cursor. I have it here. So you see, with data frames, you have what? You have your rows and you have your columns. So first column is numeric, second is logical, and third is character. So these are the columns. You know, we define them here. So this is one column, this is another column, this is another column. All right. So this becomes our data frame. Okay. So it's quite interesting when we do some of these things. Now let's look at something here. It's important we also look at it. We've been doing this, but then in programming, obviously, you may do some arithmetic operations. Okay, you may do some addition, subtraction, etc. So let's take a look at some example. Let's say basic arithmetic operations. So I'll start with addition. So in addition, let's say 3 plus 7. So the plus is the addition. So you have your 10. You can assign the whole operation to a variable. So let's say total. It becomes 3 plus 7. So now if I say print total, I get what? 10. Now what about subtraction? Let's see how that is also done. It's also very, very simple. So we have it here. Let's correct it. So let's say 10 minus 5 or 6, whichever one. So the minus symbol you have on your keyboard, that's what we use. So 10 minus 6. That gives you your answer. Again, you can assign to a variable. Multiplication, we use the star symbol. That's a shift and 8 will give you the star. So let's say 3 multiplied by 2, that's 3 star 2. That will give us our answer. So the star here, when you check your keyboard, okay, for mine it's shift and then 8. That will give me the star symbol. Okay, so that's for multiplication. For division, let's say 10 divided by 2. That's how we do it. And you get your answer. All right, so you take note of all these things. And of course, with division, let's say 5 divided by 2. This one will give you a float. Okay, so depending on what you want, you can add other functionalities to fine-tune your answer. Okay, like in situations like division. All right, so you take note of that. Of course, we are going to do some detailed tutorials to cover some of these concepts, but for now, this is the beginner's edition, so we are keeping things simple so that you can easily understand and enjoy R. So let's proceed. Okay, so let's do this. That's for division. Now, there are situations whereby you may want to execute certain functions or certain tasks based on certain conditions. All right. So we say conditional statements. All right. Or let's say conditional commands, whichever one. So conditional statements. So there's whereby you execute a function. Or let's say you execute a task. Let me put it that way. Where you execute a task based on certain conditions. Now let's look at this situation. Okay, let's say DNA seq. Let's put it this way. This is a character, right? Now let's say you have a criteria that this DNA this sequence here, if the length is greater than, let's say, 6, you want to classify it as a long sequence. If it's less than 6, then it's short. Okay, so let's do this. Let's have these two situations. There's another one. Let's say if the length is greater than 6, is termed long, then for a conditional statement in R, that's how we do it. Here's an example. So we use the if statement, and then the condition, okay, comes in brackets like this, right? So here in my brackets, I want to check if the length, okay, is greater than 6 or less than 6. So then I can just say ncar DNA seq like this. Okay. As a beginners, this also, we can make it very, very simple first. So what I can do is I can just say seq length. I'll do it this way first. So I'll say seq length is equals to ncar DNA seq 1. Okay. So I want to find the length first. Okay. So DNA seq 1 is not there because we need to define it properly. So I'll do it again. Perfect, now it's done. This is done. So what I want to do is that I want to check if the length of this sequence is greater than 6. And if it's greater than 6, I want to display the statement a long sequence. And if it's less than 6 or equals to 6, then I want to say it's a short sequence. Then we now do this. So I'll say if, now bring my condition in this bracket. Now I'll say seq length is greater than 6 by this. Okay, so please take note of this. If seq length is greater than 6 by this, let me just close the spaces here. So if we have it like this, we need to bring a curly bracket. Okay, I'll bring this in the next line. So what it means is that if this condition is true, then something should happen here. That is where the curly brackets comes in. So in between the curly brackets, we put what should happen. And so what should happen is that we want to print long sequence. That is if this length is greater than 6. Okay, so let's execute the statement. Now we have our seq length. So let's run it. Perfect. Now it says what? It's greater than 6. Now if we check the seq length, print seq length, if we print it here, it's 7. So that means this statement holds. Okay. Now again, this very one here, if we are to execute it separately here, notice something here. It gives us a logical value which is true. In other words, if this statement is true, then we should have this happening. Right. Now, it's not just about true. You can add another thing. So that means that if it's true, it should happen. Else, something else should also happen. So here, let's make a copy of this. Let's put it here. And let's add something else to it. So here it says if the condition is true, this should happen. So if it's not true, then we can say else. And this else to bring a curly brackets like this. Right. So we can have it like this. Right. So in we put in our statements. So we can say what? Let's say print short sequence. Right. Now when we execute this, it's still long sequence because the seq length greater than 6. Now let's say the seq length we are assigned this to ncar of DNA-seq2. Okay, like this. Now seq length, if you print it, if you print seq length is 3. So now if I execute this script or this group of puts, it gives me short sequence because now it's no longer greater than 6. It's less than 6 or less than or equals to 6. So it's a short sequence. So this is for the if statement, or let's say conditional statement. Again, for conditional statement, there's a detailed tutorial on that. So for those who wants to, you can check that one out. All right. So this is just an intro. So what I want to do is to just pay attention here and then look at the explanations for this and then try to reproduce them. Okay. So there's a simple statement. All right. Now let's look at something else here. Okay. We are going to look at another thing here. Okay. Now let's look at loops. Right. So loops allow us to iterate over items and then process them. Okay, so it's important to also take a look at that. So in other words, loops are a sequence of instructions that are continuously repeated until a certain condition is met. All right. So in our case, for example, what we are going to do is to use loops to display the individual nucleotides. Okay, it's that simple. We are going to use a very simple scenario here. Okay, for detailed explanation and a detailed video, just check the description box for that. Okay, so loops has advantages. It can help us to process items, not only nucleotide, but a whole lot of things, which as we climb the programming ladder, we will get to know. So for now, let's do a simple loop here. So let's create our DNA-seq variable again. Let's say ATCG, or this time let's even say bases, nucleotides. Okay. Now, if let's say I want to print or display them one by one, then that's what I'm going to do. Right? I can do this. I can say for, that's a for loop. Again, I have to bring something like this. That's a condition. Or yeah, I say for base in nucleotides. and then I'll proceed. Then I bring my curly brackets, and then say print space. And let's do this. Let's see what happens. Now, if I do it this way, then I'm going to get something like this happening, because everything is taken as a single entity. Okay. So here, there are different approaches to go about this. Okay, you can just put it as a character vector. All right, you can just say as a character, and then let's run it. Okay, so now you see what has been done. Okay, so in some situations you may want to convert your data into into vectors, and then vectors or lists, and then you can get the appropriate output. Or there are other ways too that you can use. For example, you can use the str split also, but these are things we'll talk about later. But for the most part, you can do well by using vectors and lists as well. So some outputs will depend on the data type you are using and the format. So I'm just giving you different scenarios that you can work with. Of course, if you want to book a session to learn R, that's so great. I have some links you can use. So just book a session below, and then I will get back to you. Or send me an email and we can arrange a session. So this is just an example. Okay, now let's look at functions. There's also another important thing that you need to know. It's very, very important, because you will need to, at a point in time, repeat some tasks and automate some tasks. So what are functions? A function is a collection of codes, like what we are going to do now. So this collection of codes, you can always call them and even supply some values. Then these codes will work together to generate your output for you. So it's a collection of code that you can always call to perform a certain task. So that's what basically a function does. So one advantage of functions is that it can help you to perform tasks repeatedly without you having to rewrite the codes again. Okay, so whenever you want to perform the task, you just call that function, and then all the codes under that function will execute or will be executed, and then the task that you want to achieve will be achieved for you. So basically that's what function is. Okay, so let's look at it. So it's just like, let's say you have, let's say, a washing machine. All right, so a washing machine comprises of several components that will do the washing and do rinse and all that stuff for you. So whenever you want to wash your clothes, you don't have to go to the store and buy the washing machine again. All I have to do is the one in your house. You just power it on, you put in your clothes, and it will wash, and so you get your wash clothes out. So your output in this instance becomes your wash clothes. So just put it in that way as a function. So a group of codes, a collection of codes that you can call to achieve or to perform a certain task for you. Okay, so let's proceed with that. So let's continue. So we will write a simple function here, okay, to do all these things. Okay. Now, before I even talk about function, let's actually go back. It's something that we need to do first. So in the mathematical operations that we had, let's go back. There's something that we can also do here, which I thought we can do. That is to calculate the EC contents. Okay, it's something that we can do first. So I want us to do this one first, and then after that we will come back to the function because it ties in perfectly to it. Okay, since we are dealing with DNA sequences, okay, it's important we try something else here. So there's like a simple project. So let's say calculating the GC contents. Okay. So it's also under basic arithmetic operations, but let's say you have your DNA sequence. Let's say DNA seq have JTATCG. Let's say something like this. Okay. Now, if you want to compute GC contents, you need to first get the length of the sequence, because you need that information. Just check here, because you know it's the total of your G's and C's divided by the length. So you need your sequence length. So here it becomes what? NCAR DNA seq. And then what do we also need? We need the G count. And here what we do, we use what? str as for counts. We say DNA seq. And then we say what? G. So you notice it's tying perfectly. Okay. So we have G counts. And we also have what? C counts. And that will be what? DNA seq C. Right? It's perfect. Then now finally, the GC content is what? The G count plus the C count divided by length times 100. So GC content comes what? G counts plus C counts. You notice I've placed them in brackets. Divided by what? Seq length multiplied by 100. Right? So we have something like this. So I'll run it. Now if I type GC content, what do I get? We have it here. Of course, you can refine it further, but for now, let's just keep it like this. So this is another example of a mathematical operation or arithmetic operation you can perform. Okay, so this is what? Calculating GC content. All right. Now, if you have this, sometimes you can have multiple sequences. So if you want to compute the GC content, you don't have to rewrite all these codes again. And that's where functions come in. All right. So let's get back to functions here. And let's try to write a function that will compute the GC content for us. Of course, with the GC content codes, we can still make it very, very simple. We can use a one-liner command, but that is for advanced users. For those who are advanced, there's a way to make it very simple. For beginners, I'll have to take you through step by step. So that's why we are computing them step by step. But it's possible to have a single one-liner command, which we can do later on. All right. So let's proceed. So to create a function, you first need to give a name. So I have calculate GC _ content. That will be the name of the function. And then I'll say function. We need this keyword. Then we say sequence. Because here we want to use an input. We will always apply an input. All right, so that's why we are putting this as a placeholder. Then that's what I'll do. Then we have to bring a curly bracket. So we have two curly brackets, but ideally, let me just say it's an advice. So the first one, second one, and then in between them, you can put in your quotes. So again, with GC contents, you need to get a length, the sequence. Okay, so I'll just say seq length. And that'll be what? NCAR sequence. So this sequence is a placeholder for whatever we are going to put in. I repeat, the word sequence here is a placeholder for whatever sequence we will specify. All right, so that's what we have here. Now we need a J count, J count, and that'll be what? SCR counts, sequence, and then G. So now add a C count, which is what? SCR counts, bracket sequence, and then C. All right, now that is done. So now what can we do? We will now say GC contents, and we say what? We bring it in brackets and we say J count plus C count, all in brackets. Then we say divided by seq length, multiply by 100. Now let's display the results. So we say print GC contents. All right. We just want to keep it simple. You can also use the return statement here, but for now the function should just print the output for us. All right. So let's run this, and then let's do this. Let's call the function. Okay, so we'll use an example sequence. So I'll say DNA seq. Now say, let's say A, T, C, C, G, C. Try any sequence of your choice, that's fine. Right? So I'll run it and I'll call the function. So I'll say calculate GC content, and I will say DNA seq. So let's run this. Here's what we now have. It says 50. Okay. If you check, total of 6, but the G's and C's total is also 3, so 50. Now let's use a different sequence. Let's try this. Nice. Now we have this also there. Okay, so it's good. So you can use a return statement so that the whole result can be assigned to a variable. So we use a return function, but that's something that we'll cover in later tutorials. Okay, so just take note of that. Okay, so it's very, very simple here. Okay, so that's for the function statement. I repeat, that is it for the function statement. Now we are going to do something else, which is also very, very important. Let's check it out here. Let's look at it here. Okay. So now what we are going to do next is to do a bit of data manipulation in R. All right, so I'll say data manipulation in R. All right, so we have that also here. So here, what we are basically going to do is to import and export data. All right, so in R, it's possible to read data, okay, from an external source. All right, so for this situation, we just want to read data from online. All right, and then also save it to an output. Okay, so what we are going to do is to look at this page here. One of my GitHub repos. Let's look at it here. So I have something like this here. I want us to look at it. Okay. So we have some data sets here. This malaria data set, which I've used a couple of times for machine learning tasks. I want us to read this data, or in other words, let's say import this data to R. So there's one GitHub. And I have the link. So if I want to import this CSV file, this data here, I need the down link to the file here. So when you come to raw, right click and then go to copy link address. Okay. Alternatively, you can click on raw, and when you click it, you'll be sent to another page. Okay, or you can also click to download, but you'll send to another page and you can copy this link. This link that is being shown here, this one. So copy it and then place it in R. Okay, so that's what we are going to do next year. We are going to import the data. By this time, we are importing it from online. I can also import from a local machine, that's fine, but this is publicly available. So let's use that one. So let's go back to RStudio and then let's import the data and then also export. We can import and also export. So let's start with the import. I'll just put that here. So I can say case data and I'll say read.csv. Okay, and I'll put everything in quotes like this. Now paste. Okay, like this. Okay. Now for those who are not comfortable with this approach, let's even make it simpler. I think it's better for everyone. I'll make it this way. Let's say data source equals, I'll bring it in double quotes. Please make sure it's like this and then paste your link so that they are what in the 2 double quotes or 2 single quotes. It's like this. Let me just make it smaller so that we see what I'm talking about. Let's make it smaller. And later change it back, that's fine. But I want us to see how this is. So it should be something like this. The data source, the link you copied should be in double quotes, like we have the first double quote, second double quote. There should be no space. Okay, there should be no space between the v and then the double quote. So that's what I want you to do. Now I'll enlarge the text again so that we are all okay. So I'll enlarge it back to 12. That's what I was using previously, right? So we have defined the data source, right? So that's what I want you to do. Then when we come here, I'm going to read the data or import. So I'll just say case data, and I'll say read.csv. I'll put the data source there because there's a variable, we have defined it here. So here it can even be the path to the file you have in your system, that's fine. So that's a simple approach. This is a CSV file, so we are just going to read it in this way. It's very, very simple. So let's run it. And now I have it done. It's still reading. Okay, so that is also done. Now I can export this data. Okay, I can export it as well. But for now, before we export, let's even do some quick exploration. Okay, you can do some exploration on it. So here's what I'm going to do. If it's a data, once you open it, you need to explore a bit. Okay, so we can say since it's a data frame, let's even do the class first. So class case data data.frame. All right, that means rows and tables. So that means we can find a number of rows and number of columns. So I can say dim case data, and I'll get it here. So 220734 rows and columns. Right. I can also check the column names. I have it here, and then I see all the columns here, right? And see them here. So we see all of them here. Okay, so we are still exploring. Okay. Now this is a basic, or let me just say this is an intro. So a detailed video for data manipulation and exploring is in another tutorial. So just check the link, you'll find that. So this is just to get you started. So we can have the column names. Now let's say we are interested in a particular column. Let's say this one here. I think I will send this up a bit. Let's say we are interested in clinical diagnosis. We just want to go further. Right? You can just subset it. You can just say, let's say subsets. You can say case data. You bring your square brackets. Comma means all rows. And there's comma. And you can say clinical diagnosis. There are other ways to go about this, but let's keep it simple for now. Then let's run it. When you run it, you get all these there. Right? You can still open it using the spreadsheet software, by the way, and then see everything because it's a CSV file. Now we have all this. Let's just say you want just the values. Okay, you want to remove all duplicates. You can still use the same command. At this time, you say unique, and then you place that command in it. Right, and that will give you just those main phenotypes. So you can have something like this. Okay, now let's export. Let's say you want to export this data, I mean the one you just imported. So to export, you can just say write.csv. Here it's case data. Then you give an output file. Let's say exported data.csv. You can add other options as well. That's fine. Okay. Then you can write it. Okay. You can write it, and then when you write it, it's saved on your file, on your system. Let me put it that way. So you now have to go and check your system and find out where that data has been stored. So it's stored. So in RStudio, you can come to this side, files. Okay, so when you come to files, so if this is where your working directory is, then you should see the exported file there. So for example, I see mine here. Okay, and it also tells me the dates, okay, that I modified, which is today. So I see that here and I can open it, okay, if I want to, but this should tell you that I have exported that file. Okay, so this is also one thing that you can also do with the RStudio. So you export, you can explore, you can check your files without you having to exit or quit RStudio. Okay, so that's something you can also do. So it's a very cool thing we are doing here. Now let's look at the last one, which is data visualization. Here it's also an intro. So what we are going to do is to generate a simple bar chart like I showed earlier on when we started this tutorial. So let's just do a simple bar chart. Okay, R has some inbuilt function for plots. And there are other packages too, like ggplot, etc., that can help you do advanced plot. But let's keep it simple here. There's an intro. So let's say I want to plot a bar chart. We need values, of course. So I'll just say snip count. And of course, you see my C. That means what? The number vector. So I have 17. Let's say 10. Let's say 2. Let's say 13. Now, with bar charts, I also need some labels. I'll say sample ID. Again, what? Character. So this time, it's a character vector. So let's say P001, P002, P003, P004. You have it this way. This is a simple bar chart. Okay, let me correct it here. It's a bar chart. Okay, so a simple bar chart. I've corrected a typo. All right. Now we also have this. So here we first define what? The values. Okay. Values to be plotted. Now we plot. So what we can do is to say bar plot. We plot what we want to plot. That's snip count. name.arg. This will be used as labels. We say what? Sample ID. Then we can say xlab, that's label, and say sample or samples, whichever one you want. Right? Then comma in R. So the comma should come here. So we can have ylab equals number of SNPs. Okay, comma again. We can come to the next line. That is fine. Okay, we can come to the next line, but the bracket should still be there. And we can say color equals, let's say green. We are given a color. I can choose to leave it out anyway. Comma. And then main, that will be title. We can say SNP count. And now we can run it. So let's run this. Perfect. So now we see everything has been done nicely. All right. If you don't want the color, that's great. You can just remove that option together with one, the commas, and then run it again. So it gives you a different thing altogether. Okay, so we have it this way. Now I'll reverse by using Ctrl Z to get back to my previous command, and I'll run it again. Right, so perfect. So now this is very, very nice and cool. Okay, so this is it. All right, so in a nutshell, if you know programming, for example, R, it becomes easier for you to do analysis, handle large data, manipulate, and it also makes you very flexible. Okay, with programming, it allows you to do a lot of things. You can customize, you can remove, you can add. There are a whole lot of things. So at the end of the day, it depends on what you want. All right. So if you're a beginner and you still want more tutorials, one-on-one session, you can always reach out to me. We can arrange and we can work things out here. All right. So this is the R programming for Bioinformatics Beginners Edition, and I'll be making more content which will be detailed. So the detailed tutorials are going to highlight on the different things I've talked about here, and then those who want to learn more can learn more. Those who are also interested in Python, I have a playlist for Python for beginners and advanced users. So just check the description box, you'll find links to those videos. All right, so this is how we do it, and I will see you in the next session.